Okay, in this video, I'm going to show you how to factor trinomials when the first leading coefficient, which is a, is 1. So that basically means there is not a visible coefficient in front of the first term. All right? Now, the method that I'm going to teach you in this video really relies heavily on your knowledge of the FOIL method. So if you are unfamiliar with that method or need to have a little brush up on it, please go back and rewatch the FOIL method video that I've made prior to doing this video. All right, so if you're ready, let's get started. We are going to factor this trinomial, and the word factor means part of a multiplication problem. So we are really going to just split this problem, this expression, into two parts. I kind of like to call it unfoil. I don't think that's really a word, but that's really what we're going to do. And so what I want you to draw is I want you to go ahead and draw two parentheses, you know, kind of far apart, enough to put a binomial inside each of those. And I'll kind of show you how we're going to take FOIL, the F-O-I-L, and we're going to kind of work it backwards. All right? Here we go. Now FOIL, let me just go ahead and write that word down. We have the F, the O, the I, and the L. The F stands for the first term, which in this problem, in the answer, this spot is where those first terms would be. And we would generally multiply those two together, and it would usually produce, and it will in this case, if it's in descending order, this first term right here of x squared. Okay, well, not the only one to get to x squared, because I guess you could say 1 times x squared, but I want you to put here x times x. So I'm going to erase those lines and put x times x, because I want you to have a variable in each set of parentheses. Okay, so next, this is the part where you really are going to have to think about this and think about the numbers that are involved with this specific problem. We have two more blanks to fill in. We have one in each set of parentheses. These are both the last terms, and so when we multiply the last terms together, we get this positive 40. Okay? However, both of these are also part of, like this is part of the inside, and then this other one is part of the outside number. So it's really interesting. So we're going to multiply, and this is our last term. We need two numbers so that when we multiply those two numbers, you get 40. But when you add those two numbers together, because you have this multiplication loop and then this one, when you add those same two numbers together, you're going to get 13x. Now don't worry about the x part, because when you multiply the inner and the outer, this is where you pick up that extra x. So the easiest thing, and what I tell my students in my classroom, is first, I really just want you to think of two numbers that multiply to 40, because if we don't start there, if we try to start with two numbers that add up to equal negative 13, we could fill up this whole board with what plus what equals negative 13. And we could even get to numbers in the thousands. And so that would just totally be a waste of time. But let's just think about the 40. You certainly have 1 times 40. You have 2 times 20. Let's see, what else? You have 4 times 10. And you have 8 times 5. And it looks like a pretty good list to me for now. So now I want you to go back and pay attention to the sign. We need to multiply to get a positive 40, but then we have to add any set of these numbers together to get a negative 13. So this is really interesting. because when we add, we need it to be negative, but when we multiply, it has to be positive. So let me take you back to the multiplication problems. The only way to get a positive answer when you multiply is if you're multiplying positive number times positive number, or negative number times negative number. All right, in this case, all of these multiply positive times positive to get the positive 40, but none of them add to get to the negative 13. The closest one is this one right here. That gives us a positive 13, but this problem is looking for a negative 13. However, if we take this same multiplication problem and add negative to each of those factors, okay, what is negative 5 times negative 8 is positive 40, and then when you add those two factors together, it's negative 13. So we have found our numbers. I'm going to erase these lines. And at this point, it does not matter where you put the negative 8 or where you put the negative 5. I'm just going to go ahead and put the negative 8 here and the negative 5 over here. And then when you go back, if you want to check your work, which I really hope you do, if you go back and multiply the first, x times x is x squared, and then you have the negative 5x plus the negative 8x, that gives us the negative 13x, and then negative 8 times negative 5 is positive 40. The only thing I would suggest you do is not to leave all of these loops everywhere. I would do a favor for your teacher and just rewrite your final answer, maybe even box it in so it's nice and clear what the factored answer is. Okay, let's go ahead and try another problem. Okay, this problem I'm not going to be as detailed as the previous problem was, so hopefully you're going to be okay with that. But we're going to go ahead and get started on this next trinomial. The prior example, I forgot to point out this word right here, completely. In a lot of your textbooks or online websites that you may use to answer these questions, the instructions may say factor completely, and that word completely is your clue that there may be two different factoring methods that you have to apply to this problem. And I have purposely set you up for this one to do those two factoring methods, okay? The first method that you should always try, and I should have pointed that out on the previous example, is that you always need to look for a common factor. It just takes hopefully just a couple seconds to take a look at the problem and see if there is a common factor that you can take out and then continue to factor you know, the secondary method. And so I want you to look at this problem, and you should notice off the bat that, you know, there's a number sitting in front of the x squared, and so it's probably a little clue that possibly there's something that needs to be factored out first. Now they don't all share the x term, so we are just going to look at the coefficients that they have in common. If you just by glancing at them, you can see they're all even. Our smallest one is 2, and so they probably just have the 2 in common, right? So we'll put the 2 on the outside. Now we're going to rewrite the problem with the factor 2 out. All right. Okay, so the 2 is already out. The 2, I'm just going to kind of draw a squiggly line. It's going to stay just part of our answer, okay? It's going to be 2 times and then whatever we unfoil it to. So kind of just dropped it down low because you don't want to forget it up here. I'm going to kind of work in this space here in the middle, so I'm actually going to just redraw some parentheses here. Okay, I want you just to look at the trinomial that's inside of this new set of parentheses. This is the part that we are going to unfoil to completely factor this part of the problem. the first term, okay, is what has multiplied to get x squared. So I want you to write the x times x. All right, now we're going to look for those other two numbers. These two spots, those two numbers need to multiply to negative 22 and add to negative 9. Now, think about this. The only way for two numbers to multiply to negative 22 is if one is positive and one is negative. So keep that in mind. We also want those two numbers, one positive, one negative, to add to negative 9. Now, for two numbers to add to negative 9 means the larger number needs to be negative. Okay, so let's take a look at 22. I'm just going to write out I'm just going to write the positive factors just to save some time. There's only a couple ways to get to negative 22 or 22. It's 1 times 22 and then 2 times 11. Now, one of them has to be negative to get to multiply to negative 22, and the larger one needs to be the negative to add to negative 9. So if I mark the larger one as the negative, okay, 1 times negative 22, yes, that multiplies to negative 22 for sure, but it only adds to negative 21. We are looking for negative 9. Okay, down here, 2 times negative 11, it multiplies to negative 22 and it adds to negative 9. So those are our two lucky numbers. You can plop those numbers down in any order. It does not matter. We'll put the plus 2 in the negative 11. Now, the reason I did this little squiggly line and went ahead and wrote these blank parentheses at the front of the problem is because it's really easy to stop right here and say, okay, I did it, I factored, and completely forget that we factored out a 2. So I just want you to transfer your answer down here. Okay, once you've transferred those binomials down in place, this is your final answer. One more problem. Let's do this one together. The first thing I want to point out to you is that this problem has double variables, has x squared and a y squared, and the middle term is xy. I don't want that to scare you off. It's not really going to mess up the method that I'm teaching you in this video, but we're going to have to just add something a little extra in our answer, so pay close attention. The first thing I want you to do, well, you can draw a set of parentheses, but I want you to first factor completely. So take a look at this trinomial, and is there a common factor? There's not. And so we are ready to go ahead and start unfoiling this problem. And so the first times the first is going to produce this x squared. So we'll put an x and x. Next, okay, these last terms, okay, it's going to multiply to be the negative 18y squared, but it's going to add to be the negative 7xy. Now my students are always asking, oh, but how do you get the xy part? And I will show you that. But let's first just focus on this last term right here. Now when we multiply it and it produces that y squared part of the problem, that means we need to put a y and a y in those positions. Okay. Next, we need two numbers, we need two coefficients to those y's that multiplies to negative 18 and adds to negative 7. So that part of the problem has not changed. So if you think of two numbers that multiply to 18, you have 1 and 8, you have 2 and 9, 3 and 6. I think that looks pretty good. All right. Now to get a negative 18, one of these numbers has to be negative, one has to stay positive. and to get a -7, to add two numbers to get the -7, the larger one has to be the negative one. So if I go back through here and squeeze in a negative on each of the larger numbers, now they all multiply to -18, but only one adds to -7. It's this right here. Okay, +2 and -9. You can enter +2 and -9 in any of these spots, either of them. Okay. This is your final answer, and I just want to really quickly show you how this multiplies out to look like our original problem. When we multiply x times x, this is our x squared. When we multiply x times -9y, because there's two variables, those two variables need to be written in alphabetical order. Then we go back and multiply the 2y times x. That also needs to be written in alphabetical order. And then the 2y times the -9y, there's our -18y squared. And then when you add those two like terms together, that's how you get the -7xy. So your final answer, you have factored completely to get x plus 2y times x minus 9y. Now it's your turn. I want you to pause this video and try some of these factoring problems on your own.